The last topic of this circuit is common mode rejection ratio. We all know that differential amplifier is the operational amplifier is a differential amplifier. That is, the output is produced by taking the difference of the inputs, that is the input that is applied between the inverting and non-inverting input, times the gain of the amplifier. I'm talking about the open loop output. So inherently it's a differential gain device. Now this is what we generally do. We have a voltage difference between the non-inverting and inverting input. We have the open loop gain A0, and the output is going to be A0 times the input. Now here, since we are using common mode and differential mode, so we are differentiating between the variables of the two by appending a D for differential mode. So AD, which is A0 here, AD is the output due to the differential mode, that is when the input is differential input divided by the input value. And that's a common operation that we have discussed for the operational amplifier. Now, what if you connect both the inputs to the same source? That's called the common mode scenario. Now, when you connect it, what is your expectation? Of course, the expectation should be, which is a valid expectation, that since there is no difference of voltage between the input, V differential is 0, same input is applied to both inverting and non-inverting, the output should be 0. That's a valid assumption. However, it is quite possible that the gain of these two inputs are not exactly the same. So even you apply the same input, it is possible you may have some output at the circuit. Now this condition is not a desirable condition, but this is a practical condition. That leads us to common mode and then common mode rejection ratio. So what is a common mode? Common mode is when you apply the same voltage to both the inverting and non-inverting input of the operational amplifier. And what is common mode gain? ACM, like we have AD. ACM, gain in the common mode, is the output that you see in the common mode when you apply the common mode input. That is whatever the input that is applied to both of the inverting and non-inverting terminals of the op amp. So that's your common mode output. And it may be, the gain may be non-zero, right? It may be non-zero. We hope that it is 0, but it may be, or practically it is non-zero. So what is common mode rejection ratio? Common mode rejection ratio is the ratio between the differential gain and the common mode gain. Now ideally it should be infinity, because we assume that ideally this should be 0, hence CMRR ideally should be infinity. Practically it is not infinity. In decibel, of course, you can calculate CMRR, 20 log 10 of CMRR and 20 log 10 of AD over ACM. So 20 log 10 of AD, whenever you have the division in the log, you can write it down as a subtraction. 20 log 10 of AD minus 20 log 10 of ACM. So CMRR in decibel is the difference between the differential mode gain in decibel minus the common mode gain in decibel. I put DM over here, I'm using AD, it's the same thing. So just a mistake, just remove this M over here. So differential mode gain in decibel minus common mode gain in decibel. So 741, minimum CMRR is 70 decibel and typical is 90 decibel. So observe, not infinity. CMRR is inversely proportional to the frequency. As frequency is increasing, CMRR is decreasing. If frequency is small, CMRR is large. And why do we use CMRR? In generally, we use CMRR to calibrate the operational amplifier, especially if you're using the instrumentation amplifier made out of operational amplifier. So if you have some sort of instrumentation amplifier, you want to make sure that the output is 0 when you apply the same input. Again, why? Because again, differential amplifier is operational amplifier is a differential amplifier. That is, it produces the output which is proportional to the difference of the inputs. And again, if difference is 0, then the output should be 0. But if it is not, then we have to basically balance that. We have to calibrate that. So CMRR is used. That's the figure we take if we are making instrumentation amplifier, and we have to calibrate that. But in any case, the performance of an operational amplifier is defined by how much it is going to reject the common mode. So the higher the value of CMRR, the better it is working as an operational amplifier. And then you have example 4.9, which is the last example that you can go over. It's pretty straightforward. And that concludes this chapter.